So let's start with a basic understanding of what it is that we're looking for. So what is a watt? Anybody? This is exactly why we need this. All right, a watt, I'm not going to get into technical terms, but a watt is a unit of measurement of power. How much power that something consumes, okay? What is a kilowatt?
1,000 watts.
It's 1,000 watts, there you go. What do we measure solar consumption in, or consumption of power?
Kilowatts.
Kilowatt hours.
Kilowatt hours. So what's a kilowatt hour?
Watts times number of hours.
1,000 watts
1,000 watts
in an hour.
in an hour, right? It's power over a unit of time, right? So what's a watt hour?
Number of watts over a unit of time.
Over a unit of time, exactly. So we measure things in kilowatt hours. So what's a kilowatt hour?
Unit of measurement power over time.
Over time, exactly, over hours, how many hours. So if I have something that uses 1,000 watts of energy, how much power does that use over 8 hours?
8,000
8,000 watts.
kilowatt hours.
8,000 watts.
No, it uses 1,000 watts. So how much power does that use in 8 hours? 1,000 watt hours, or 8 kilowatt hours. Right? It always uses 1,000 watts. It's a measure of power over time, right? Which is the watt hours or kilowatt hours. So this is 1,000 watts. That means in 8 hours it uses 8,000 watt hours, or 8 kilowatt hours. Does everybody understand that? Yes? Okay. Good. So, how do we figure out how much energy that somebody is using in their home? Well, first off, we need to have an understanding of what it is they have in their home. So what we need to do is we need to take a tour around with the customer in their home. So one of the reasons why we do this instead of asking them just what do they have is, number one, a lot of times they don't realize what they have, and number two, we're building trust. We're getting them to take us around their entire home. Right? This is all trust and value, right? So okay, let's take a tour. Can you show me around so we can look and see what you got? So as we go around, we're taking note. You know, we've got the refrigerator. We've got coffee machine. We've got dishwasher,
Microwave.
AC, microwave. So what we're doing is we're going to start collecting some data. So we're going to walk around with a notepad, right? And we're going to look for a tag. Every device has a tag called a UL tag. The UL tag stands for is it United Laboratories? It's a standard of that every device has to have how much power that it consumes. It needs to have data on what it does. So you'll be looking for a tag. It'll have this logo. It looks like that. UL. On that tag, it's going to have a bunch of information written, patent, and that kind of stuff. But it's going to have some numbers that you're going to look for. It's going to have the voltage rating, the amperage rating, and if you're lucky, it'll have a power rating on it. Most of the time, that one's not there, though. But with these two, we can figure out how much power that it is, that it consumes. And power is that 1,000 watts that I was showing before, right? So the way you get power is equal to the voltage times the amperage, also known as current. Does anybody know what current is? Think of it like a river. Current is the flow of electricity, right? Voltage is like the pressure, how much pressure that electricity is coming out at, and the amperage is the flow, and how wide of a river is that flow happening, okay? And that equals the power. So what we do is we would multiply the voltage. Now, sometimes things have a voltage range. So they'll say 110 to 120 or 115 to 120, or they'll just say 115, or they'll just say 120, or sometimes they'll say 220 to 240. Always take the higher. Always take the higher. So what you do is you would multiply, voltage is 120, amperage is 5, 120 times 5 would be 600 watts, which in this case, this tag had the power rating on it already. Okay, let's say that this is let's say this is a
Kiln.
fridge. What's that?
A kiln.
Oh no, that's the kiln will be way more. Let's say this is a fridge, right? This would be an energy efficient fridge, all right? Fridge is using 600 watts, and it's using 600 watt hours per hour. So, whenever you're confused, Google is your friend. What's the average amount of time that this device is on in America? Or what's the average amount of time that this is on if the customer doesn't know? So for a fridge, it's 8 hours. 8 hours a day, that condenser is running. So what I would do to figure out how much power the refrigerator is I'd look at the tag, I'd get that information. Okay, the fridge is using 600 watts, and it is using that amount of power 8 hours a day times 365 days a year. Does anybody have a calculator? Pull that out.
It's 1,800 kilowatt hours. Let's just make it 600.
Anybody?
It's 1,752 kilowatt hours.
So what is it in watts?
1.752 million. 625.
Okay. It's going to give you a number like that. And these are watt hours. And what are we always measuring?
Kilowatt hours.
Kilowatt hours. So you divide that by 1,000, and it would give you 1,752 kilowatt hours. Annually. Now for right now, until they change that metering, this is how we're going to calculate things. So we know that that device is going to use that much power. Boom, we write it next to fridge. Then we do it again, and again, and again, and again. So we need to know how much coffee that they make. We need to know how often they use the dishwasher. We need to know what temperature they like it in the house. We need to know how much they cook on the stove, on the microwave. We're asking them all of these questions because now it's on them. Now it's on them. Okay, how much do you use this? How much do you use this? How much do you use this? How often do you do this? How often do you do that? Boom, 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 boom. Now it's all very static. Now it's all very matter of fact. This is how much power you're going to use. It's not subjective. It's not, well, your house is 2,800 square feet and with 3 people, it's going to be about this much. Right? No, this is it. I walked around. I did this. I did this in your home.
So lately, I've just been keeping it real simple and doing AC, both fridges, and we know that if you look at the winter months of a home, we know that the average home uses about 300 kilowatt hours a month, depending
Again,
on
we're
size.
going subjective there.
Yeah, it's subjective, but when I did in the home the other day, telling the customer that, I added up the fridges and the AC, and then I added 300 to it, came to 1149, and I said, let me see your bill, because they had 1 month's usage. I said, it should be somewhere around 1150. Looked at the bill, it was exactly at 1150. But you can also deduce, using just those 3, the AC, both fridges, they typically have 2, what the home's using on average outside of those 3 major devices, right?
And as you get better, you'll be able to do things like that. But until you develop... Go ahead, Vince. until you develop some consistency in knowing what this is and how to do this, you can't do that. And you shouldn't do that.
Can you break it down for us on the AC side? Because don't we have to use BTUs there? Seriously?
Yes, so, will you just wait? Just wait.
Okay. I'm sorry.
Just wait like 2 seconds.
Sorry.
Alright.
Were you like, do this, then this one, and this one? It's like, well, let's not skip over AC.
So how do you figure out an AC unit? All right? Because all AC units are different. Now, when you go to the tag on an AC unit, it's not going to tell you this stuff. You're going to look super confused because it's going to have like 7 different lines that look just like this.
Figure it out.
So the easiest way is to know the tonnage, the size of that unit, and its SEER rating.
Can you tell us what SEER means?
Seasonal energy efficiency rating.
Boom.
No.
There you go. Seasonal energy efficiency rating.
Survey says.
So a SEER rating is how efficient that the unit is. I'm going to erase this.
And what is the legally the lowest they can be?
14?
I don't know that, isn't it?
You've got it 14.
Yeah, I didn't know that.
So if you're dealing with a house that's before 2012, it'll likely be 12. If you're dealing with a house that's built before 2005, it'll likely be 10.
But
As
now
far
the
as the
legal-
SEER.
But now the legal limit's 14.
Now the legal limit's
Okay,
14.
I didn't know that. So you need to know the tonnage of the unit. Now, if you can't find it on the unit itself, look at the model number, look it up on Google. That's usually what I end up having to do every time. Sometimes as you get better, you can tell just by how big the unit is, but you should never be doing that. So let's say we have a 5-ton unit. 5-ton unit. Now, this is where he talks about BTUs. There's a measurement of BTU. BTU is called a British thermal unit. And a British thermal unit is how much energy that it takes to raise the temperature of water by 1 degree. Okay? Now, for an AC unit, for each ton, there is 12,000 BTUs. Okay? Everybody follow me? So if we have a 5-ton unit, we would take 5 times 12,000, which is 60,000 BTUs. Okay? So what the hell do we do with that? Well, we need to know how efficient that the unit is. So we've got a SEER rating. So what you want to do is you want to divide this by its SEER rating. And if the SEER rating of that unit that you looked up is 14, what do we have?
4285.
Okay? So 4285 watts. This is how we're figuring out how much power this thing is going to use. This is how much power it's going to use. So now we ask the question, how much do you use it? Oh, I don't know, it just turns on and off, right? Okay, well, what temperature do you like it at? No, this is a great question. Oh, I like it at 72 degrees. Okay, so we got some ranges. We got 75 plus, 72 to 74, and then 70, or I should say 65 to 71. What you have here is 8 hours, 10 hours, 12 hours. This is how much the condenser in the AC unit, which is what's drawing all the power, is going to run based on these temperatures.
Daily, right?
Yes.
Yeah.
Daily. Daily. So, we have how much power it's going to be used. So now, based on what they tell you, This is how we figure it out. And these are annual numbers that we're figuring out. It's like, okay, Mr. Customer, I like it at 70 degrees. It's like, okay, great. We know your unit's gonna be used 12 hours a day. So I would take 42.85 times 12 hours a day times. Now here's where it gets tricky. Here's where it gets tricky. It depends on where they live, right? If we're talking to somebody in Santa Fe, it's not going to run for as much as it's going to be in Albuquerque. If we're talking to somebody in Farmington, it's not going to run as much as we are in Albuquerque, right? If we're talking about down south, it's going to run a hell of a lot more, right? Good rule of thumb is 5 months, and you confirm this with the homeowner. It's like, would you say 5 months, time? And they'll go, oh yeah, or they'll go, oh no, it's definitely longer. Oh, okay, now again, it's on them. Because this is where you're going to shock them. You're going to shock them with how much power, and then they're going to think, well, maybe I want to hold back a little bit more, or no, that sounds right. And now you've confirmed. You've confirmed with them that what you're saying is true, and that you're to be trusted, right? So let's do this. We got 12 hours a day, 5 months out of the year, times 30.42 days in a month. Now, you can do this way, or you can count the number of days for 5 months. I'd use this one because we've got a couple of 31-day months in the summertime. Hours per day, months, days per month. What does that equal?
About 5,500 kilowatts.
We don't need abouts. Being exact is the point.
7.82 million. 7,820,982.
Watts.
Watt hours.
Thank you. Watt hours. Now we measure in kilowatt hours. The easiest way to do that is just move the decimal point over 3 spots. So 7,820 kilowatt hours for the AC. This is where we're stacking it up. Stacking it up. Boom, 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 boom. We come to a total at the very end. Now we know exactly the size of the system, just like we had a whole year's worth of energy. That is the point. To be very critical and exact, to build that value and to build that trust. And you do this. This is the most difficult of the exercises, is the AC unit. And I encourage you to walk through with the customer this calculation while you're doing it. It's like, hey, let me show you how we calculate how much energy the AC is going to use. Again, building trust that we're the expert. By the end of it, we get a total. Let's say the total for this person ended up being 11,500 kilowatt hours. So now we know the number that they're going to consume. We multiply that by 1.1 or 1.15 or 1.2, depending on what we are trying to offset them at. And now we know the number we're shooting for. And when we submit our design into Enterflow, it's very simple. Please build a system that will produce 13,200 kilowatt hours. Right. You take it off of them, you take the knowledge into your hands as opposed to throwing the knowledge into somebody's hands in India or wherever the hell.
They're Malaysian.
Malaysia. Understanding your English, whatever, it's very simple and you get output exactly what you need. Question?
Another cool thing is if they're talking about going refrigerated air, you can easily deduce how many panels they're going to need before you even go in Interflow. So I have a customer I built yesterday. We'll just use their numbers for example. They have an 11,662 production. This is out of the bar graph in Interflow, and they have 21 panels right now. So if you divide 21 into 11,662, it's going to give you a metric of 555. So you can divide that 555 into the 7,820, and you know that they would need 14 panels, 14 360 watt panels in order to offset that 7,820, and that's what you would be asking the Interflow team to build you a project for.
there's so much that you can use this information for. Even if you're not doing an energy audit. Just knowing how to deduce anything and everything gives you credibility in that instant. In that instant. When we ask people, are you going to get an electric car? How do you know how much to add? Same thing. Same thing. Now, that requires a different Google search, but again, Google is your friend. It's like, oh, you're going to get an electric car. Cool. Oh, what kind of car? Oh, a sedan, Tesla. Oh, great. Well, I'm sure you know that electric cars are measured in miles per kilowatt hour, not miles per gallon. It's like, oh, yeah, I guess that makes sense. Like, okay, how much do you drive? It's like, oh, I drive, I don't know, 10,000 miles per year. It's like, great. All right, well, it says that Tesla Model 3 uses 0.26 kilowatt hours per mile. So you do that, what does that give me? 10,000 times 0.6, 2,600? 2,600 kilowatt hours of energy. Add it on. Add it on. That's how much you're going to use just to charge your car. Oh, crap. That's going to be an extra 7 panels? 6 panels? It's like, well, I mean, you could spend, $2,000 on gasoline annually, or you could spend, $4,000 right now and be set for life, right? That's the whole point. Being able to just understand these numbers and just do them on the fly is a game changer. I can tell you firsthand, I've gotten at least 20 deals doing this. At least 20. How many did I do with you? Just you? 4?
We got 3 or 4 deals out of it. I've gotten at least 2 or 3 out of it since I've been out of money. You're such a trusted consultant to them, and the math's right there in front of them. They can't lie. And if you're lucky enough to find someone who's an engineer type, and they see the math, they know they can't argue with it because they can go double check it on their own, and they'll be like, this guy's dead nuts on, sell me the system. And that's happened to us.
It has. It has.
No one else is doing that too.
Nope.
Right.
They're taking the square footage of the home
Right. Guesstimate.
and throwing it up there. I can't tell you how many times I've come in after somebody that took the square footage. I'm showing a system way bigger, but I've got the math behind mine, and I won the deal. We were $20,000 more because they trusted me more than they trusted that other person. Trust. Any questions?
No, it's awesome.
Go. Give it a shot. Hope you took notes.
All the notes.